So let's start the session. So I'm going to import NumPy as NP, Pandas as PD, and this part we have executed earlier. Just one more time, I'm executing for myself, and directly we are going into this. What are the data set, that is data extraction part. So in the last class, we have discussed about till this part by saying the various functions, out of which now we are having the data frame like this. Now from this data frame, I want to select a particular column. We already seen how to select a particular column by using df.age or df of age, something like this. In this way, we can select the particular column. Or for example, if you are having with respect to any particular record, if you want to select any particular record, okay, and how to select an entire record, how to select an entire column, and in a particular record, I want to select a single value. I want only this single value. I don't want the entire record. I don't want entire column. I want exactly on the single value. I want from this one to this one. I want from here to here. As per my requirements, I want to select the data. As per my requirements, I want to select the data, which is called as data extraction. So here in the data extraction, what we are going to do is we are going to select the data as per the requirements. Now in this, the data extraction, out of we are having three options. Okay, three different ways to execute this one. Out of which the first one is by using the conditions. By using the conditions. Conditions means you are going to write the condition. If you remember in the last day before yesterday's class, we have discussed that is NumPy. In the NumPy, one of the option I have told you the concept called as fancy indexing. Do you remember? Okay, what is meant by this fancy indexing? So in the given array, what are the array of values? Within the array of values, just you are going to write one condition, and whichever the values are accepting or satisfying the condition, and that output we are going to get. This is called as fancy indexing or mask indexing. So for example, here I have taken the A values, and whichever the condition, this condition I have given, if I write only the condition, since it is a comparison operator, the output will be either true or false. At the end, the comparison operator's output is either true or false. But I want the records. To get the records, we have to write A of, again inside that condition. A of condition we have to write. Now here the condition will give either true or false, and A of means wherever the value is true, that value will be printed, right? That we have seen in the NumPy. The same thing as it is in the pandas. Now here, just observe this one, df of gender. What is meant by df of gender? Df of gender means gender column. You are selecting the gender column, single column. Equal to male. What is meant by equal to? Whether it is checking whether it is male or female. So you are asking comparison operator. Since it is a comparison operator, it is checking whether this is a male. No, false. Male, true, true, true. Again here, it is neither true or false with respect to false. False. Sorry, true. False. False. True. So it is going to select like this. So just if you observe this one, just I have written the condition. Now I have got the output as either true or false. So I don't want the output either true or false, sir. I want the output of the records wherever the records are equal to male. The records you want to get means you have to write the syntax of df of condition. Instead of writing a normal condition, you have to write df of condition. Now, whichever the condition is satisfied, those records in that particular df will be printed. So now same as NumPy. In the NumPy, how you have written the condition inside, outside you have to write the NumPy array name. Similarly, here also the condition, this is the condition. The outside you have to add the pandas data frame. I'm adding the pandas data frame, that is df of condition. And now I'm going to get the data which satisfies the male records. In my data set, I'm having these are the records which are male records. And similarly, I want the female records, whichever satisfies the word of female. So I'm going to get the female records. Right? So if you want male records means male records, female records means female records. Like this, you are extracting the data by writing the condition from this. For example, assume that I'm having total in this classroom, Google Classroom or whatever the students are there. I'm having total 180 students in this 730 batch. Okay. 105 students from online, 75 students from offline, total 180 strength. Now, out of this 180, I'm having each student record. So I'm having the student name of the student, and email of the student, and phone number of the student, and what is the fees of the student they have paid. Now here, the course was completed almost 1 month. Now we have to pay the second installment. Now, if you don't pay the second installment, I'm going to remove those records from the Google Classroom. Now this is the condition. Now for that condition, what we have to do, whoever has not paid, I'm going to give the full amount. Whatever the fees amount is there, that fees amount, whoever has not paid the fees amount, I'm going to get the data. For example, let us take the first installment. Whoever has paid the first installment, minimum of 7,000 rupees or 7,500 rupees. For those people only, I have added in the Google Classroom. Now, what is the condition I have applied at the time is DF of fees. Whatever the fees is there, fees greater than or equal to 7,000. And this is the data. And now I have got the records, list of the records. In that particular records, now whatever the records I have got, this one I have stored in the data frame, new data frame called as fully paid students, partial paid students, PPS. I have stored in a variable called as PPS. Now in this PPS, only the students who have satisfied the condition of whoever has paid the fees of 7,000. Now within this PPS, I have selected the email column, and I have got the list of emails, the column name. And this one I want to store in an array. So dot values. Now whatever the emails list I have got, everything I will get an array, one array I will get, right? That array I have copied in the Gmail, in the Google Classroom. And I have given the invite. And this one also, I can create a software, automatically it will do everything. Just you have to input the data only, it will only do everything. You have written the condition like this, and what are the values, and the list of values will be there. For loop it will apply, and every time it will add into that one. Automatically Google Classroom will be created automated. The steps if you are written is automated, everything. Now just you are writing the condition. Based on the condition, you are extracting the data. Within that data, again, you want only the email. So you are going to separate email records. I don't want the phone number or mail, name, nothing. I want only the email in order to add into the Google Classroom. So just we are selecting whichever the records are satisfying my condition. So I'm writing one condition and I'm just observing whichever the conditions, right? Now here, see, if I'm saying about automate, okay, automate or automatically it will do one by one miss. For that, we have to write the code now. For that, we are learning. To create that one, first we have to write the code, right? So the code, how to write the code? For which students we have to add the into the Google Classroom is, for that we have to extract the data. For what you are going to do for IN. So for example, I will show you a list, students list. Name is there and fees paid is there. Out of which one student has paid 10,000, one student has paid 7,000, one student has paid 5,000, one student has paid 12,000, one student 15,000, 20,000, 20,000, 15,000, 7,500, 10,000. Something I'm having like this. Now within this, I want to select whoever the student has paid more than 7,000. First, you are going to write the condition and you'll identify this particular student has not paid that one. Right? So here, just since the number of students are very less, you can identify with your eyes directly, sir. You can say that this is a less number of students now. You are not paid, you can clearly see now. Since you are having with respect like this, now assume you are having 10 lakh records. From top to bottom, you can't see, right? Every record, you can't see the values, right? So at the time, we are going to apply the condition. Now, whenever you have applied this condition, what it is going to do? Just in the back end, it is just applying the for loop. For each and every value here it is applying for each and every value. It is checking whether it is a male or female for each and every value. Whenever you use the word of each and every value means the meaning is for loop. Just it is applying the for loop And for each and every value, it is male, 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 whether it is equal to male or not, it is checking, cross-verifying, and it is applying the condition. In the backend, that is written with the for loop for I in given list. Whatever this particular column, it is going to select that column, and it is selecting the value which is equal to male or not. If the answer is male, means it is going to append to the empty list. If you append to an empty list, if you select the empty list and if you append every time, it is a NumPy array. That NumPy array, if you convert to data frame, finally it is a data frame. So in the backend, NumPy and for loop only is working. Every code in the backend is for loop only. For each and every value, it is going to do. And whichever the condition, whichever the record is satisfying, it is showing only true or false because you have given the comparison operator. Now, if you write like this, the syntax, if you write like this, now it is going to give the data. Now you have extracted the male data, whichever the male data you are having, you have extracted the complete male data. Now, if you want to save that one, save it as a male data. Similarly, write the condition for female and save it as a female data. Now you start analyzing, okay, for males, how many of them are having liver problem, and for that, what is the reason? Means which values are having the input. So male data you have separately analyzing, female data you are separately analyzing. Now you are writing the condition like age. Age is greater than 70. Now it is identifying whichever the records are satisfying the age of 70. Right? Now, sir, I want to write the multiple conditions. Just how you have written in this earlier, the same thing. Once again, it is same. So just where you have taken this operators, during the operators I have told you how to apply the multiple conditions and logical or not. Logical or, logical and not. We are having in the Python. Similarly, here also we are having with logical or and logical and. The logical or in this one is represented by symbol like this. This is with respect to or. And is taken as and like this. Instead of writing A and D, OR words, in core Python we have written OR. In core Python we have written A and D. But in pandas we should not use the word of A and D. We have to write directly the symbol of A and D only. Okay. So this is the syntax in the pandas. So now just it is applying the condition. First it is going to check for each record whether the age is equal to 65. Condition number 1. Condition 1 is age is exactly equal to 65. Condition number 2 is gender should be female. Now it is going to check in the original data frame. The original data frame is this one. In this, first it will check for the first record. Either gender should be female or age should be 65. Satisfied? This is true. This is true. True or true. Output is true. So this record will be selected. Now this one condition is false and this one also false. False or false. Output is false. So this condition, this record will not be selected. Next, false or false, not selected. Next, false, false, not selected. Exactly equal to 65. Na? So again, it is also false and this is also false, not selected. False, false, not selected. False, false, not selected. False, true. False or true. What is the output? True. True means record will be selected. False and false, record will not be selected. Now, for your conditions, how many records are satisfying that one miss? These are the 2 records. Record number 1 is index 0 and record numbers index number with 7. These are the 2 records which it is satisfying. So you are going to get the same answer. Whichever the record satisfies your condition, those records will be extracted. Since you have written the conditions, multiple conditions, it is applying multiple, either of. If you have written or miss or end, if you write end miss, both of them should be true. Then only that particular record will be selected. If one of the thing is also not satisfied, also it will not select. So here see, liver patient is equal to S. Liver patient, you have to get S. At the same time, age also should be greater than 70. Both the conditions are true. So that is the reason it has been selected this record. And if you are having or and end, both of them you are having. Now first priority will be given with respect to logical and followed by logical or. The same way. Here also the same way. It is going to apply the same logic. Right? Now, how to select this filter, sir? Yes, or. That in the given condition like that is there. Can you tell me any one record which is satisfying? Select any record apart from those two. The given data set is not having anything like that. Okay. Now, sir, how to write this filter, sir? And how you have written the conditions? Condition will be dependent upon you. You have to select whether you have to select age of 70 or age of 40 or that you have to decide. And after deciding for that, what is the code you have to write, that I am showing. I'm not saying about the condition. For example, in this class, now I'm having the certain students are there. Now, whatever the certain students are there, now I'm going to check how many of them are non-IT background, from non-IT background, and how many of them are IT background. How many of them are freshers level and how many of them are non-freshers, that is experienced people. Now, why I'm doing this one? Because it is going to be helpful for my explanation in the class. If many of them are IT students are there, it is going to be a different. If many of them are non-IT students are there, I have to give with a different examples. For my teaching, for which one, how I have to teach. For my given data, for my given students, how I have to teach means first I have to understand about the students. Now I'm going to extract with respect to the values with non-IT, IT. So based on that, I'm going to decide. Sir, how you are going to discuss with respect to the students, and everything is as per my requirements. For my requirements, I'm writing the conditions. For data set to data set, the condition will changes. Right? Is that clear? Next, second one is ILOC. ILOC. I stands for index. Loc stands for location. You are identifying the index location. What is meant by index location means index number. Using the index number, it is going to work. You are going to select the data by using the index numbers. Earlier example, we have extracted the data based on the condition. We have filtered the data based on the condition. Now the same data I'm filtering based on the ILOC. Okay. Any particular row you want to select or any particular column you want to select, you have to using the index number how to extract the data. Now, what is the syntax for this one? Miss, write in your notes very clearly. df dot ILOC. df dot ILOC. And you have to give a bracket, square bracket. Square bracket indicates you are accessing the index numbers. In between, you have to write the comma. Now, before to this, row index numbers, row index, and you have to give the next one is column index. If multiple rows you want to select, list of rows. If multiple rows you want, miss, list of rows, list. If multiple columns you want to select, miss, list of columns. Only one column you want to select, miss, only one number. Multiple rows you can write like this, anything of your choice. Right? Now, example. Let us take with an example. df dot ILOC of row index number, I'm going to select 0. Column index number 5, number 5. Now, what is the value within the row index number of 0? So let me open once again the df. I'm opening the df here. Okay, instead of moving backward, I'm opening here itself. Now in this ILOC of 0, ILOC of 0 means 0 index number. That is row index number is 0, this line. Inside this line, column index number of 5, that is 0, 1, 2, 3, 4, 5. Now this value you are going to get as the output. So if you write this one, df dot ILOC of first one is 0, 5. You are going to get output as 16. This value. Is that clear? So just it is selecting this particular row index number and column index number. So this single value, like this, you can extract the single value. Okay. Now, if you want to extract with multiple values, sir, I want the list of values, sir. So list of, write the list of row numbers. I am selecting the list of row numbers like this. df dot ILOC. Row numbers are 0, 4, and 6. column index number is 5 only. Now column, what is there in the column index number 5? This one. In that, 0 index number is 16. And with column index number 4, 27. And column index number 6, 16. 16, 27, 16. These three values I'm going to get. That's just I'm writing as a list of 0, 4, 6 and bracket. Now I'm going to get 16, 27, 16. Sir, I want with respect to columns also like a df dot ilog of 0, 4, 6. Okay, sir. Rows, okay. Columns I want to select index number 5 and index number 6. These both of them. 2 columns you want means list of 2 column names. If you want one miss, write single number. Whenever you want multiple miss, you have to go with the list, obviously. 5, 6 miss, 16, 18, 27, 59, 16 and 12. You are going to get like this. 16, 19, 27, 59, 16 and 12. Sir, I want instead of selecting this 6, can you go with 8? Side by side? No, side by side. It is not mandatory to go with the side by side. Directly you can go with the next one also like this. So that particular column will be selected. If you want 2 columns means 2 columns, 3 columns means 3 columns. Like this, you can extract whatever the data you want. Okay. For example, let us assume the data I want is this one. This value, this value, this value, this and this. Now, what is the code I have to write? df.ilog row numbers are 0 to 5. 0 to 5 index numbers, row index numbers of 0 to 5 and columns of 0 to column index numbers, that is 0, 1, 2, that is 2, 3, 4, 5, 6, 7, 8, 9, 10, that is 10. Now automatically you'll get the values like this. So if you write this one 0, 2, 5 and columns of 2, 10. That is 0 0.7, 7.3, 1.8. Yes, yes, yes. Is that clear? Now, sir, from 2 to 10, everything I want. All the columns from 2 to 10, but rows of 0 to 5 only. Rows are 0 to 5. That is very clear. But columns I want from 2 to 10. Instead of writing 2, 3, 4, 5 like this, no need to write. Directly write the slicing. From 2 to 11. 11 means automatically 10 only. Na? Slicing operator will not applicable, the last one. So 2 to 11 you have to write. So go with the 2 to 11. So 2 with respect to 11. 2 to 11. That particular 3 rows from that particular column to that ending column. Okay, slicing. Directly you can apply the slicing. Sir, alternate. I want to alternate. If you go with this one, with 2 step also possible. Step also possible. Alternate columns will be selected. First, this column is selected, followed by this column, followed by this column, followed by this column, followed by this column. In the columns, you are giving this one. Sir, I want from here to here, sir. This one is the data I required. So for that columns, what are the columns you want? 0, 1, 2, 3, 4, 5. So 6. So 2 to 7. You have to use the 2 to 7. 2 colon 7. Okay. Now rows 0 to 4 you want. So what you have to select? 0 to 5. So I'm going to select 0 colon 5. Up to 4 index number I'm going to get. Right? So either you can apply with respect to slicing or with respect to single number, or you can write the list of numbers. Sir, I want, if there is a pattern is available, first number of 0, followed by second one, fourth one, sixth one, eighth one, you want alternate means slicing you can apply. You can add the 2 every time. Slicing you can apply. But there is no pattern is there. First this one, you want this one, followed by this one. Then from where we can write the slicing? So slicing operation cannot be applicable for this. So then we have to write the list of 0, 1 and 7. In this case, we have to write like this. If pattern is available, miss, go with the slicing. Pattern is not available, miss, what are the numbers you want, you write. Okay. So for example, 0, 1 and you want the 6 and 7. We can't apply the slicing operation. Pattern is not there for that. Whereas first one, this one, followed by this one, followed by this one, miss, pattern is available. Every time you are adding 4. So 0 to 9 with an increment of 4, miss, first 0 record, followed by 4th record, followed by the 8th record, it is going to select. The last number will not be included. If you don't write the last number also, it is going to select all by default. Whatever the slicing operation is there, the same concept will be applicable here. Second number, if you don't write, automatically. Similarly, index numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the positive index numbers. Negative index numbers are -1, -2, -3, -4, up to -11. Both positive indexing is possible, negative indexing also possible. Both the scenarios. Whatever you have done in the list slicing, string slicing, the same concept will remain entire Python. That is the reason in the string slicing, I have told you that remember this one, and in the entire complete Python, it is going to be the same. During the strings only, I have told you that one. And at that time only, I have explained very clearly how it is going to move. Either in one direction, either in the forward direction or backward direction, but it will not completely takes the both the things. Right? The same concept will be applicable. Similarly, df dot ilock, and you have given only 0. You have not given the second number. Okay, you have given only one number. By default, it is going to take all the columns. By default, all the columns. If you don't write also, by default, this is the one. So if I write df of ilock of 0, miss, you are going to get the row, 0th row with all the columns. So first row, it is getting printed the first row. Whatever in that row, it is there. So you want with respect to 7th row, index number 7, that you are going to select. That, but all the columns will be, if you have written only one number, miss, all the columns. Sir, if I write df, all the rows, sir, but columns are first column, that is index number 0. Now, why it is not considering as the column name? Why it can't consider as the column? Then you have to give the comma before, give the empty. Then it will take that all the rows with column of 0. Then it will understand in this way. Now, if you go with this df dot ilock of all the rows, comma, after comma only it will understand that it is columns. Till that it will not understand the columns. If you don't write like this, miss, rows only, all the columns by default. When you have written the second one, automatically it is going to take all the rows with first column. It is going to select the first column. Rows is all the rows. Is that clear? Similarly, df dot ilock of -1. Can anyone tell me what is the output of this? Now, automatically, what is the column? All the columns. Row number of -1. Similarly, how we are having the positive indexing for the columns, same kind of negative indexing for the columns, positive indexing and negative indexing for the rows also. So rows also 0, 1, 2, up to 8, -1, -2, -3, row indexing also. So now -1, df dot ilock of -1 means automatically it is going to set the last row with all the columns. Now here you have written like this, df dot ilock of 3, 7, 8. This is of everything of rows only. Columns are automatically. Sir, how the Python will understand that one? This is the main bracket, which is indexing. Now you have written only 3, 7, 8 without using the bracket. Without using the bracket, if you have written like this, now it is going to throw an error. Because before comma, this is considered as row index number, this is considered as column index number, then what is this one is called as? It is going to throw error. If you don't use the one more bracket, it will throw an error. See, just observe this one. Too many indexes are there. You have to give only 2. Before 2, 1, after 1. So here you have used it 2 times comma. Sir, my meaning is 3, 7, 8 row numbers, sir. That you understand. How Python will understand that you have to give the bracket like this. Now, after the bracket, if once you have given the bracket, the first bracket is considered for the rows. Now, for columns, automatically all of them. By default, all of them. When you have written this one, so now clearly you can see this bracket for the rows, this bracket for the columns. Now that particular columns will be selected. In this way, we can access the single value. We can access with respect to the list of values. Is that clear? That is using the iloc. Iloc is based on the index number. Based on the index number. Now, the same data I want to extract by using the loc without using I. Loc. Next option is called as loc. Now, loc is nothing but, once again, location. This time the location will be based on the name. Whether it is a row name or column name, whatever it is, name, not number, name. It is going to work on the name wise, not as the. So now if you ask with respect to df of 0, df dot loc of 0 means it is going to take name with 0. Name with 0. What is there inside the name with? Now tell me. These are the column names. Everyone knows. I don't need to specially tell this is the column names. So column names. Now column index numbers 0, 1, 2, 3, 4, 5. Because in the Python the index number starts with 0. So this is also index numbers. These are called as index numbers. These are called as column names. Both of them are clear. Coming to the row. These are the index numbers. What is the row name? By default, both are same. By default, in this case, both are same. I will show you one more example where both are different. I will show you next one. Okay. So here I am having with respect by default, the name and the index number for the row is same. Whereas for the columns, the names are different, index numbers are different. Now, if you are asking iloc of 0, it is going to check 0 of name wise. It is checking name wise whether 0 row name is there or not. Is available now. So it is printing. Now, if you ask df dot loc of -1, if you ask with respect to -1, what happens? It is going to check name with -1. Index number of -1 is available. Name with -1 is there? No. It is going to throw an error with key error that -1 name is not available. It is going to say that -1 is not available. But if you use the same thing with iloc, it is going to work. Last row automatically. Index number na. I miss index number. Without I miss name wise. Now this is the interview question for the data scientist. What is the difference between the loc and iloc? They are not going to ask the code. They will ask in the theoretical only. Theory only they will ask. What is the difference between iloc and loc? You have to say the answer. Sir, iloc works on the index number, whereas loc will work on the name wise. One is working on the number wise, one is working on the name wise. They will not ask you in the interview that df.iloc, df.log, like this. They will not ask with respect to data frame, nothing. They'll ask only in the orally. What is the difference between iloc and loc? Is that clear? So loc of -1 means it is checking the name with -1. Not number with -1. Index number with -1 not. It is checking with name wise -1 is available or not. And similarly, next it is going to do this one. See, df.log list of 5, 6. Row names of 5, 6 I want. Column names with TB to TP I want. Now TB to TP. If I open the df. Okay, I'm opening the df. TP to TB to TP. From here to here I want. Now, what is the index number of this one? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you give here, instead of TB index number is 2. If you give the 2 here, and here if you give with respect to TP, till TP you want miss, you have to give the 8. Now, if you give like this, it is going to throw an error because it is going to check whether the column name with 2 is available or not. It is not checking the column name with 2 is there or not. It is not checking the index number because you have used the loc. Instead of this, if you use the iloc, it will work again. It will work because now it is working on the index numbers. Now, whenever you're using the lock, automatically it is going to throw an error. It is checking with the name wise key error. Again, it is going to throw an error name called as index numbers are not available with this with names. Right? Now, here what I'm going to do is I'm going to change this one to TB to TP. Now, TP will be included or not? Miss, TP also will be included because TP -1 can't apply now. Index -1 will be applicable. For column name, how for name -1, how you can apply? SRK -1. What is the answer? You can't say, right? For example, 40 -1 miss, okay, 39. SRK -1 miss, this is not applicable now. So the last one also is going to consider. The last column also will be considered. So you'll ask the question that, sir, in the slicing, the last one should not be applicable now, basically. That is for index numbers. If you go with the index numbers, miss, then the last one is not applicable. But you are going with the name wise now. For name, -1 will not be applicable. So it is not applying that concept here. Right? Now df dot lock colon comma means all the rows of TB column. You are selecting the TB column with respect to all the rows. Rows is everything from starting to end, everything. Starting number you have not given, ending number not given. Means starting is by default the first one, ending is everything. Right? Now, so just make sure and don't confuse with the differences between the lock and iLock. So here df dot lock of 2 comma age means it is going to check the row name of 2, column name of age. Similarly, here it is going iLock of 2 comma 0 means index number, row index number of 2, column index number of 0. Okay, so it is working based on that. Now, I told you earlier that I will show you one more example with different row names. That is you can get by using the df dot set index. Now, this TB column, whatever the TB column is there, this TB column, I'm going to use the index as the index. Now, whatever you are seeing here, these are the names. These are the names. Now, for this first record, what is the name? Name of the row is 0.7 is the name. 10.9 is the name. 7.3 is the name. 1.0 is the name. 3.9, 1.8, 0.9, none, and 0.9. So 0.9 2 times repeated means 2 members are there with the same name. If you ask with respect to, sir, if I, for example, here, these are the row names. What is the index numbers? 0 to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. That is common. This is the row index numbers. This is the row names. Column names are this one. Column index numbers are this one. Now you can see the names and index numbers separately. Generally, which we are going to use, which one we are going to use in the set index means whichever is the unique values are there. Unique values like, for example, student names are there. Student names I am going to use in the index numbers, in the index portion. Right? Now, if you want to access, okay, if you want to access this one, L1, this I am going to store in the data frame called as L1. L1 dot lock of 0.9. Now, it is going to check the name wherever the name of 0.9 is there. 0.9 here and here. So it is going to give me the output of 2 values. I ask the list of the list which is satisfying the condition of 0.9. Now, lock of 1.0 DB to ALB. 1.0 means here it is going to check row name with 1.0. It is working with 1.0. If you ask 1 also, it is going to check like this. So here 1, this is the name 1. Now if you are asking with, instead of that, if you are asking with 1.4, is there any name with 1.4 in this? So it is going to throw an error that there is no name with 1.4. No name of 1.4. Okay. The names are considered as keys. Right? Now, next one is, again, you want to bring back your things means reset index. Reset index again will bring back to the original data. Okay. So now whenever you are resetting the original data, automatically the index will get into the first position by default. Now, few students will ask me the question, sir, instead of getting in the first position, can I bring this one into this position, something? Though it is in the first position, though it is in that position also, for us, both are same. Now tell me what will be the difference if the TB is in this column, if the TB is in the first position, what is the difference you will find? How it is going to impact you? Tell me one difference where it is going to have the difference. Assume this is in the last column, the last but one column. It is in the first position. Now tell me what is the difference for you? Axing will be the same and calculation will be the same. Conditions will be the same. Conditions are not dependent on the based on the position of the TB, right? If you want to see for the in the given data, for example, this is selected in a hospital. Okay, let us assume there is a hospital near to your house. Okay, so near to your house, one hospital is there. In that, patients are there. Multiple patients are coming. Now, in that patients, whatever the age, the name of the patient, age of the patient, and the disease of the patient or issue, health issue of the patient, you have written the data. Records are there. Now, for this particular hospital, more number of patients will be greater than 60 or less than 60. That you want to analyze. Means in this particular hospital, more number of old age people are coming for this particular hospital. For that, what you are going to do? DF of age greater than 60 or greater than or equal to 60. And this particular records you are going to get like this. And whatever the records you have got, number of records divided by total number of records, that is length of DF. If you calculate with length of DF, automatically get the percentage. How much percentage of people are coming for this hospital with greater than 60 age. Right? So now why 60 only you have considered? Because you want to analyze how many old age people are visiting this hospital. That is your requirement. For that requirement, this is the code. Sir, my requirement is how many people are visiting less than 25. How many patients are less than 25 in my particular hospital? Write the condition. Write the condition and you will get the records with respect to 25, less than 25. If you go with the normal hospital, if you go with a normal hospital and if you write the condition with less than 20 or something like this, you have written the condition. Now in that you'll get total 1000 patients are there. With respect less than 20 means maybe 20 members or 30 members only will be there. In a normal, if you go with Yashoda Hospital in Panjaguta or whatever it is. Now, if you go the same thing with the Rainbow Children Hospital, means out of 1000 patients, almost 990 students, 90% or 99% will be with respect to them only. I can even write 1000 also, but deviation, error. I can't say with 100% probability, I can't predict anything. So 990 people. In that particular Rainbow Children Hospital, this condition is different. In Yashoda Hospital, the condition is different. Every hospital, every patient, everything will not be the same. Now, for example, in your hospital, you are having, let us assume there is a hospital. There is one hospital called as Yashoda Hospital. And in this Yashoda Hospital, you are working as a data scientist or data analyst, some analyst role you are working. Okay, in this hospital. Now here, we are having with respect to the related to heart, that is cardiology department is there, right? And in that doctors are there, around 10 doctors are there. But still the patients are saying that in the Yashoda, we have to wait for more time. Something news like this is there. And that feedback has received to the Yashoda team. That though this many doctors are there, this much facilities are there, still outside the people are thinking that they're waiting for so much of time. Now what they want is, first they're asking that total number of patients in Yashoda Hospital, that too in the cardiology. How many number of patients are visiting daily? Now what you are going to take? Date, you are going to take the date in the index number. You are going to keep that one in the index position and you are going to select with respect to date is equal to today's date, that is 10/11/2022. You are going to write like this and you are going to extract today how many patients has visited and how many doctors on duty. And each doctor, how many patients they have treated. That is today's data. Like this, you are going to generate the data and you are going to generate a report and you are going to submit to the Yashoda team. Now, if it is okay, miss, they are going to modify accordingly. Otherwise, they will hire the more number of people. Based on your report, they will hire the one more doctor, if required, one more doctors, or if the doctors are sufficient and patients are sufficient, still the feedback is like this. They will discuss with the doctors. They'll have a meeting with the doctors. Doctors, please, this is the scenarios was going on. Please do this one. All these things will be done based on analysis. The report we have to generate. To generate the report, first we have to extract the data. This data, after extracting the data, for example, on the 10th, total 100 patients has visited. The same thing you have to represent on the bar, 100 people on the 10th. On the weekends, if it is high miss, bar will be like this. If it is low miss, the bar will be like this. So the same thing you are going to represent on the graphs. For graphs, you have to represent miss. First, you have to get the data now. Using the data, you are going to represent on the graph. So to generate the graphs, data is required. For the data, we have to write the conditions. For that, data extraction part is important. Okay. If you understand today's class very clearly, SQL is one day for you. Just it is one day. Whatever if you know the pandas, SQL is one day. Okay, in order to learn or in order to get that one, right? This is not with respect to YouTube thumbnail, really only. Really only SQL will be the easiest one if you know the pandas. If you want, I can start the SQL also. Even the next tomorrow's class, I can start it even with the SQL, and I will integrate with the same thing in the SQL, and I will show you the pandas code for the same data set in the pandas, how to write the code, in the SQL, how to write the code. Once you see the difference in your entire life, you will never open the SQL also. Always you will work only on the pandas. Instead of writing the SQL code, you'll write only the pandas code. But SQL, how we can work on using the pandas, how the data we can get, that is in the database, this is in the Jupyter notebook. How? Integration. For that library called as SQL library. One library is there for that one also. In that one function is there called as connection. Connect that one, get the data, do in the pandas. Finally, we require the data and we have to generate the reports. For how we have done using the pandas or using SQL, no one is going to ask you that one. So then no one is going to ask me, then we can do anything, miss? Yes, in the companies we can do anything. But in the interview, they'll ask SQL separately. For that, we have to learn SQL. If they don't ask in the interview SQL, miss, directly we no need to read also SQL. For data scientist, SQL also not required. That you'll understand later. Don't worry, right? But only one thing is, in the SQL, how we are going to extract the data. SQL is nothing but, you know, what is meant by SQL? SQL is nothing but structured query language. This is also one of the language name. How the Python is having the language name called as Python. English is having the name as English. This is having the name as SQL, language name. There is a database. Database means it is going to be some space in your system. One location will be there. In that, data will be there. The data will be in the tabular format. And you have to extract the data by writing some kind of code. By writing the code, you have to extract the data. This code is as per your requirements. Right? The same thing, for example, here, I have loaded the data. This is the data. And I want the columns. For example, name, age, and gender. These are the columns are there. Now, once you have got the data, now you have to write in the pandas to get the data of age column. What is the code you have to write? df of age. Now you'll get this particular column of age. The same thing if you want to write in the SQL means select age from table name. What are the table name? df is then a df. This is SQL code. This is pandas code. Answer is same. Data will be the same. There will be no difference, not even minute difference. This is pandas code. This is SQL code. Now you want the two columns, that is df of age and gender. So you are going to take as a list age of gender and age. This is pandas code. Select age, comma, gender from DF. This is SQL code. Answer will be the same. Right? This is pandas code and this is SQL codes. So if you understand pandas means SQL is just 1 day. Right? 1 day is also more. Okay. It will not even take 1 day also. Okay. Now, just by writing the conditions and we are going to extract the data. The next one is called as group by. Now group by and value counts and cross tab. These are the things which we are having, out of which the group by option we'll see later once we complete the statistics, because here I'm going to apply the mean concept. Again, I have to explain the mean and all these things. So let me skip the group by now. Okay, during the statistics, once again, I will explain this concept. Now, next one is value counts. Value counts means it is applicable only for categorical data. How many categories are there? For example, in your data, gender is the heading is there. Inside that, what are the categories are there? Male and female. And if any third category is there, the third category. Only 2 categories are there, means 2 categories. So just you are going to extract the data and each category and their number of counts, how many times it has been repeated. That is df of gender dot value counts. So total in my data set, 5 females are there, 2 females are there, and 5 males are there in my data set. So each category and their counts. Category and their counts is given by using the value counts. Similarly, liver patient, that is 8. With respect to 8 of them are yes and 1 of them is no. 2 categories are there. This value counts is applicable only for the discrete variable, categorical variable. Right? Now, if you want in their percentages, 8 and 1 out of 9, and you want divide by the length function, you'll get the like this percentages. 90% of the data is with yes, 10% of the data is with no's. Either like this or like this. Normalize is equal to true. This one or this one, both are same. Either you can write like this. Sir, it is difficult to remember this one, miss. Write divide by total. Just it is going to apply 8 divided by 9, 1 divided by 9. Total. Just it is going to apply divide by total number of records. That is nothing but value counts. Value counts means each category. Value means category. Each category and their count. Count of each category. Right? Is that clear? Yes. Normalize is equal to true means just it is applying the percentage. Normalize meaning is percentage in terms of percentage. Right? Now remaining whatever the group by and cross tab is there, this both we are going to discuss once the statistics is completed. Okay, theoretical part of statistics we are going to start tomorrow. And during the practical part of statistics, at that time, I will explain this group by and cross tab, remaining balance 2. Right, guys? So that is the end of the session for today.